Or how infinite series look and how to use the summation notation, let's actually go ahead and compute some sums. There's not much more to the introduction. Let's go to it. So we're actually going to be concerned with these things called partial sums, okay? S1, S2, S3, and so on. So if I have a series, okay? If I have a series here, okay, let's draw it here. If this is my sum, okay, the sum from n equals 1 to infinity here, okay, then sk, the partial sums, means that we just sum from the first term all the way up to the kth term. That means we're going to look at this. Sum from n equals 1 to k of an, okay? This is akin to a definite integral here, okay? And in fact, if you're really clever, okay, if you're very clever, you don't have to like always generate all the terms every single time. I'll show you what we mean here. Let's take a look at this guy here. I want to compute the first four partial sums of this series. We're summing from n equals 1 to infinity, n over n plus 1. So let's go ahead and identify what our sequence is. This guy in the yellow, our corresponding sequence here, an, is just n over n plus 1. Okay, now for the first four partial sums, we are going to need the first four terms. So let's go ahead and write them out. Okay, so our first term here, we just plug in 1, that's a half. A2 is just 2 over 3. A3 is 3 over 4. And A4 is 4 over 5. So we have all four, our first four terms. Okay, that's easy enough. But now we want these partial sums. So how do we think about S1, the first partial sum? Well, we're summing from n equals 1 to, well, in this case, if you look there, k is equal to 1. So we're summing from 1 to 1. What does that mean? That's just literally the first term. So our first partial sum is our first term, 1 half. Okay, let's fix that. Now what about our second partial sum? Well, we need to add up the first two terms. We're summing from 1 to 2. Okay, so we need a1 plus a2. Now notice here that since I already have a1, which is really s1, okay, I'm doing a1 plus a2, but notice that a1 is the same as s1. So it's just the previous partial sum plus the next term. So that's a half plus 2/3. And if we consult my notes here, we do the fraction reduction, that's 7 over 6. Okay, we're in business now. So now what about S3? Okay, so S3 is adding up all the first three terms, A1 plus A2 plus A3. But that's the same as taking the previous partial sum, S2. Okay, well, let's write it like this. Okay, A1 plus A2 plus A3. Okay, but we've added up already the first two terms, A1 plus A2, that's S2. So we take the previous partial sum, add on the next term. Okay, so the previous partial sum is 7 over 6 plus the next term, A3, that's 3 over 4. And when we do a bit of arithmetic there, okay, it's a bit of magical arithmetic, we get 23 over 12. Okay, and finally S4, I think you can see the pattern here. Okay, S4, we just add up the first four terms, but that's the same as adding up the third partial sum plus the fourth term. So we have 23 over 12 plus, what is the next term here? What is the fourth term? 4 over 5. You do some arithmetic, and that sum comes out to be 163 over 60. Okay, and so there you have it, your first four partial sums. Okay, easy enough. You're just adding up a bunch of things. Okay, the sequence gives you a way to determine what things you're adding up into the series. Okay, let's take a look at another one here. This one looks a little complicated. Okay, minus 1 to the n times n plus 1 all over n factorial. Okay, so that n factorial is there. We got to remember what the factorial is. Let's recall what that is real quick. Remember that n factorial means that we multiply all the integers down to 1. Okay, so 4 factorial, that's 4 times 3 times 2 times 1. Okay, in fact, just see that as an exercise. Let's go ahead and write down what the first four terms are. Okay, so again, we'll go ahead and highlight what our sequence is. This is our sequence an. Okay, so an is minus 1 to the n times n plus 1 over n factorial. That's how we generate the terms. These are our summands. Okay, so now let's look at what a1 is, okay? Well, minus 1 to the 1 is a minus 1, okay? Then we have 1 plus 1 there, divided by 1 factorial. And 1 factorial is just 1, okay? And so we get a net result of negative 2. A2, okay, now remember, this is not the partial sum yet, we're just looking at the term. So the second thing that we'll be adding is plug in n equals 2. Okay, so we do all that. Negative 1 squared is a plus 1, and 2 plus 1 is 3. And 2 factorial, that's 2 times 1, 2. Now let's look at A3. The third term in the sequence here, we have negative 1 cubed times 3 plus 1 over 3 factorial. Well, negative 1 cubed is a negative 1. 3 plus 1 is 4. And then the 3 factorial, okay, let's think about it. 3 times 2 times 1, because we're counting down to 1. 3 times 2 times 1 is 6. When you reduce this to 2/3, then you can probably see that A4 will come out just as easy. 4 factorial is just 24. We have plus there. So we have 5 over 24. Okay. So now we have the first 4 terms in our sequence, and now let's go ahead and get the first 4 partial sums. So as we saw above, the first partial sum is literally the first term, and that first term is just negative 2. Now for the second partial sum, we just have to take the previous partial sum, add the next term to it. We have negative 2 plus 3 over 2. And what does that give us? That gives us, let's see, negative 7 over 6. Okay, if we, nope, that is negative 1/2. I'm looking at the wrong line there. Okay. What is our third term? Our third partial sum? It's the second partial sum plus the third term of the sequence. So we take the previous partial sum, that's negative 1/2. Okay, let's fix that. Okay, negative 1/2. And then we'll add on the third term, so minus 2/3, and now it's negative 7 over 6. Okay, and then S4, the fourth partial sum, that's the third partial sum plus the fourth term. So minus 7 over 6 plus 5 over 24, okay, equals, well, if you do the arithmetic, negative 23 over 24. Take a look at that, the first 4 partial sums. Now, I want you to think about this as we move on to the next video. Take a look at these first 4 partial sums and probably try to compute these, okay? Compute the next one. Compute, like, say, the 5th and the 6th and the 7th, maybe. Or, write some computer code to do that, okay? All this summation notation is just a for loop, okay? So, for you Python folks, this is just a simple for loop, okay? Or you can do a while, okay? Same sort of thing. But take a look at these numbers here, okay? These guys, okay, they look to be getting very close to a certain number, right? Maybe. But what about these here for the previous one that we just did? Well, are they getting bigger? Are they getting close to a certain number? We're actually going to answer that question in the next video, okay? Because right now, all we're concerned about is how to compute these partial sums. And just like we had convergence of a sequence, you'll see that we got a sequence of partial sums, so it might be natural to ask the following question. Does a sequence of partial sums converge? And I'll see you in the next one.